Welcome to 1.4 Squeeze Theorem. The word squeeze means in between two things, and you're being squeezed, so there's like no room. This person here is squeezed, is currently being a squeeze between the rock and the wall. So this is an example of squeeze. What does that mean in math? Let's say that we have f of x, and f of x is really complicated. So we don't know what it's like. So in fact, here's a function. This is f of x. It's really complicated, right? So it looks like this. You're like, right? We want to know the limit of this function. Let's say we want the limit as x approaches 0. It's probably 0 for this one. It looks like a 0, but we can't be sure. It looks like a 0. How can we prove that? Well, if we can find two other functions, a of x and b of x, I'm going to use blue for a of x. So a of x is always smaller. Like a of x maybe looks like this. That's a of x. Whereas red is f of x. So f of x is always bigger than or equal to a of x. And we'll find a bigger function, b of x, that is always bigger or equal to. So this is b of x. So we see that f of x, the function, f of x, is being squeezed by a of x and b of x. When that happens, well, if we know that the limit for both a and b right here is 0, if the limit of a of x is 0, the limit of b of x is 0 at x equals 0, as x approaches 0, then f of x must have the same limit, because it can't be bigger than b, and it cannot be smaller than a. In math, we can say that if the limit of a of x as x approaches c is equal to the limit of b of x as x approaches c is equal to some constant L, then the limit of f of x as x approaches c must also equal to L. We can see that here. So here's our function. This function is x squared times sine of 1 to the x. That's hard to figure out. I mean, there's no really easy way of calculating. So the limit of f of x as x approaches 0 is difficult to calculate. Okay. But we know that sine of t is between -1 and 1 for any t. So we know that sine looks like this, right? It goes up and down, but it's never bigger than +1, and it's never smaller. It's never bigger than +1. It's never smaller than -1. So it's bounded by +1 and -1. That's true for any t. So if t equals 1 over x, that means that sine of 1 over x is also between -1 and 1. Okay? Right? So that means that f of x is equal to x squared times some number between -1 and 1. That's what it really means. Then, let's say that means we can let a of x is equal to -1 times x squared, which is just -x squared. Then f of x is then a of x must be always smaller than or equal to. To type in smaller than or equal to on Google Slides, we can go to Insert, Special Characters, draw it, click on it. Yeah. So that means that a of x is always less than or equal to f of x, right? And if we let b of x is equal to plus 1 times x squared, which is just x squared. Yeah, because f of x is always x squared times some number between -1 and 1. Then f of x is always less than or equal to, I'll just copy and paste here, b of x. Okay. But what's the limit? Well, the limit of a of x as x approaches 0 is, we can plug in negative times 0 squared, which is 0. Similarly, the limit as x approaches 0 of b of x is equal to positive 0 squared, which is also equal to 0. Well, by the squeeze theorem, well, f is always between a and b, but a and b have the same limit as x approaches 0. That means that f of x, so limit of f of x as x approaches 0 must also equal to 0 as well by the squeeze theorem. So this is difficult to calculate, but we figured out the limit by comparing it to the limit of two other functions. What does it look like graph-wise? Let's go to decimals. Here's our graph of f of x. A of x, we said, is always less than or equal to is f of x. This is negative x squared. Yeah, let's use a different color. Okay. See, a of x is always less than or equal to f of x, and b of x is always greater than or equal to f of x. So no matter what we do, red is always stuck between blue and green. F is always stuck between a and b. So if both a and b approach 0 as x approaches 0, f must approach 0 as well. And that's the squeeze theorem. Okay. For homework, for this assignment, you will be working on 4 problems on Khan Academy. To get credit, you need to get 3 right. The link is given in your Google Classroom. To be able to figure out those problems, we have to think about when can we use the squeeze theorem. Well, squeeze theorem only works if f is between a and b. So f must not be smaller than a, it must not be greater than b. And a and b must always have the same limit. Okay, so that's it for the squeeze theorem.